Hello, fourth graders, and welcome to your Unit 6, Session 2.1 session. And today we are going to be looking at fractions that are greater than 1. I want us to take a peek at this fraction right here. I want you to think about, how do I say this fraction? If you were thinking in your head 3 halves, that is exactly right. Is there any other way that you know how to write 3 halves? I'll give you a moment. Go ahead on your paper, write another way for 3 halves. Think about this as you're writing it. Is 3 halves greater than 1 whole? Could you write 3 halves in another way, maybe as a mixed number, using 1 whole and a fraction? Let's think about that. Well, I know my numerator lets me know how many pieces I'm working with, how many pieces to shade in maybe. And my denominator lets me know that my whole is divided into 2 pieces. So do you think that we could show this on maybe a 4x6 rectangle? Pause the video right now and get a 4x6 rectangle. Okay, so you have your 4x6 rectangles. And I want to know, how could we use these 4x6 rectangles to make a picture for the fraction 3 halves? Let's pretend like these rectangles are sandwiches, maybe peanut butter and jelly sandwiches. And I ate 3 halves of a sandwich. How could I show 3 halves of a sandwich? How could I use these 4x6 rectangles to show 3 halves of a sandwich? Now, ask yourself before you start shading it in, is 3 halves more or less than 1 whole? How do you know? How many halves are in 1 sandwich? How many halves are in 3 halves of a sandwich? Does it help to look at this fraction in 2 different ways? We know that when our numerator and our denominator are the exact same number, then we know it equals to 1 whole. So if you said 3 halves is greater than 1 whole, pat yourself on the back. That's exactly right. But now we're coming into a situation where the numerator is greater or bigger than the denominator. We call this type of fraction an improper fraction. And we call it an improper fraction, there's the prefix m, because it's not proper. It's not what we're used to seeing. We're used to seeing the numerator number is smaller than the denominator number. As long as you know the jobs of what the numerator does and what the denominator does, then you'll be able to show this problem on your 4x6 rectangles. So, we know that the denominator tells us that we have to divide our rectangle into 2 equal pieces. So I know that I need to draw a line right down in the middle of my 4x6 rectangle. Just like that. I have 1, 2 equal pieces. Now, my numerator tells me how many pieces to shade in, or how many pieces we're working with. How many pieces are we talking about, boys and girls? If you said 3, that's exactly right. So I'm going to shade in 3 parts. So there's 1 piece, 2 pieces. But wait a minute. My numerator says that I'm talking about 3 pieces. And I've only been able to shade in 2 pieces. So what do I need to do? Well, if you said I need to create another whole and divide it into 2 pieces, you are exactly right. So here's another whole. I'm going to divide it into 2 equal pieces. Now I've shaded in 1, 2 pieces, but my numerator says I have to shade in 3 pieces. So I'm going to shade in my 3rd piece right here on my other whole. Now, this was an improper fraction because the numerator was bigger than the denominator. I asked you the question, was this improper fraction greater or less than 1 whole? And we said it is greater, because 1 whole would be 2 halves. So we have 1 whole rectangle shaded in, but what do we have here? We have 1 half shaded in here. So we're going to write this improper fraction into what we call a mixed number. A mixed number has a whole number. There's our whole rectangle shaded in. And it has a fraction. And this fraction would be 1 piece out of 2. And we say this mixed number as 1 and 1 half, because there is 1 whole rectangle shaded in, and there is half of another whole rectangle shaded in. So 3 halves is equivalent or equal to 1 and 1 half. Now, what if you shaded it in like this? You knew that you had a whole, and you knew the denominator told you to divide your whole into 2 pieces. And you wanted to shade in 3 pieces. So 1, and maybe you, instead of shading in the other piece there, you went to another whole, divided it into 2 equal parts, shaded in 1 part. There's 2 parts shaded in. And then you went to another 4x6 rectangle, divided it in half, and shaded in the 3rd piece. My question to you is, does this representation of 3 halves, is it equivalent or the same as this representation of 3 halves? Think about that. Do both of my representations show 3 halves? If I eat the shaded parts in the first picture, these shaded parts, and my friend eats the shaded parts in the second picture, did we eat the same amount? Yes, we did eat the same amount. How are the 2 pictures, this picture and this representation, how are they the same? Well, in this picture, I shaded in 1, 2, 3 halves. In this representation, I shaded in 1, 2, 3 halves. Also, in this representation, my whole was divided into 2 equal parts. In this representation, my wholes were divided into 2 equal parts. They are the same. How are they different? How is this representation of 3 halves, or 1 and 1 half, different than this representation of 3 halves, or 1 and 1 half? Well, one way you may look at it is that in this representation, I shaded in 1 whole and then half of another whole. But in this representation, I took 3 wholes and I only shaded in a half of each whole. Does 1 half plus 1 half plus 1 half equal 3 halves? Yes, it does equal 3 halves. And you are going to be working more with this in the next few days. All right, you may pause your video for now and head on to your next assignment.